to the next page, which is about multiplying polynomials. So this is when we have more than just a monomial multiplying by a polynomial, but we have two different expressions that have more than one term each. This is not really a new concept. We just have to make sure that we distribute everything that's distributing. So I'm going to start over here, actually. To multiply polynomials, multiply each term in the first polynomial to each term in the second polynomial, and then combine like terms. Okay, so we have two different methods. I'm actually going to start over here, and I'm not going to call it FOIL for right now. I'm just going to look at this. I have, here's a binomial. I'll highlight, here's my red binomial. And then I also have this second binomial. They are multiplying together. So all together, I have 4 terms. So at the end of the day, I should have 4 terms once I have multiplied, because everything in this binomial needs to multiply by every term in this binomial. So I'm going to actually just write this as 2 separate distributions. So I'm going to take this x and I'm going to distribute it to x plus 4. And then I'm going to add to that the 2, and I'm going to multiply it by x plus 4. Okay, so really I'm just taking this binomial and I'm separating it into, here's the distributive property and here's the 2 being distributed. So we know how to handle this. This is just like what we were doing before. I'm going to do x times x, and that will give me x squared, and x times 4 will give me 4x. Over here, I'm going to do 2 times x, and that will be 2x, and 2 times 4, and that gives me 8. Notice right here, those are 2 x terms. Remember, when we're adding, things that have a different exponent are not considered like terms. So this x squared would be considered a different kind of term. That x squared is a different kind of term than these two that both have x's, and it's different than this 8, which is a constant. It can get confusing when we do a lot of multiplying. We want to change the exponents. We want to, use our product rule. But remember, when we're adding, we're only going to change the coefficient. So I'm going to have still just an x squared. 4x plus 2x will be a total of 6x's plus 8. So this is my final answer. Okay, so we just did that, just separating it into 2 separate distributions. And you can always do that. However many terms you have here, each one will be a separate distribution, right? We're going to take x and distribute to every term. We're going to take the 2, distribute to every term. So I can rewrite it however many terms I have, just as different sets of distributive property. Sometimes we use this acronym FOIL, and let me see. Okay, FOIL stands for multiply the first terms. So my first 2 terms would be x and x. So that is my first 2 terms. So that would be x times x. And then we want to, the O stands for the outer terms. So that would be these 2. The x and the 4 are the outermost terms, which would be 4 times x. These 2 right here are the inner terms. So that would be 2 times x. And then these ones are my last terms. So plus 2 times 4. That stands for last. So FOIL is an acronym. You're going to hear some teachers use it like a verb. Like, we're going to FOIL this. All that means is we are going to distribute every term of the first binomial to every term of the second binomial. So when I multiply that, I'll get x times x, x squared. 4 times x is 4x. 2 times x is 2x. And 2 times 4 is 8. I will still get those like terms right there. So I get the same answer. This is basically a way to think about, here's first and outer terms. That's what this is. This is multiplying the first and the outer term. First term to the outer term. This is multiplying the inner term to the inner term and the last term of the first binomial to the last term of the second binomial. So FOIL is really just kind of a way to think through, I need to multiply every term of the first binomial to every term of the second binomial. So there's my first distribution, and here's my second distribution. So first, outer, inner, last. This just makes sure what happens, what the mistake lots of students make is they want to take x plus 2 and x plus 4, and they want to do this one, x squared, and they want to do that one, 8, and they want to be done there. But we saw with both of these methods, we need to get the inner and the outer terms multiplied. We don't want to forget those. We don't want to just do the first and last. So make sure we always remember we have to do the outer and the inner ones as well. Okay, let me show you though. I could take that same problem and we could do a visual approach. I could think of this as like a table. I could think about like, here's my x. Oh, that's highlighter. Here's my x. No, that's red. Let's try again. Here is x, here is 2. So I've got a column each for x and 2. And then I'm going to make rows for x and 4. X and 4. Now I can think about the same thing. I want to multiply every number in the table by every other number. So I'm going to do x times x. This box gives me x squared. I want to do x times 2, which will give me 2x. I want to do 4 times x. That gives me 4x. And then I want to do 4 times 2, which is 8. So notice this was multiplying by my first two terms. This would be multiplying by the outer terms. This is multiplying the two inner terms. And this is multiplying my two last terms. And then I can see I'm always going to have right here, if I have a binomial, a linear binomial with another linear binomial, you'll often see the like terms right there on that diagonal. So when I to finish, I would say x squared. I would combine 4x plus 2x to get 6x, and then plus 8. So these are just 3 different ways. I can write out each distribution separately. I could do FOIL where I'm doing the same thing here, but I kind of do upper distribution and then the bottom distribution as well. That's your FOIL. Or I can use the box if I want a more visual model. So I'm going to show probably a few examples of each of these methods just so that you guys can watch and see. You do not have to do all the methods. You can choose which one makes the most sense to you. I know sometimes this makes the most sense just to see, oh, I'm just distributing twice. After a while, though, you might get to the point where like you can see, oh, I just distribute there, and you might not have to write out the step, and you're just doing FOIL method, basically. But some of you may love the box method, and you can just always use the box method. So let's do an example here with the box. My first binomial is k and -4. My second binomial, I have k and +5. So once I have that set up, I'm just going to go for each square. I'll look at what's multiplying. This is multiplying k and k. That gives me k squared. My next box, I'm multiplying k by -4, which is -4k. This box, I'm multiplying 5 by k, which gives me 5k. And then my last terms are -4 and 5, so that's going to be -20. Then I notice these two are like terms. They both have k with an exponent of 1. So to write out my answer, I will write k squared. 5k minus 4k is just 1k left, minus 20. And there's my answer. Okay, for number 2, I will write out the 2 distributions. So I'm going to take, highlight every term in this binomial and multiply by every term in that binomial. So I'm going to have 2x times x minus 7 plus negative 10 times x minus 7. So there's my two sets of distribution. I'm going to distribute the first term to the second binomial and then the second term. So when I get 2x times x, that will be 2x squared. 2x times negative 7 is minus 14x. I'm going to distribute this one. I'm going to make sure I bring with me that negative in front of the 10. So this is going to be negative 10x, and then negative 10 times 7 is plus 70. These two are like terms. So 2x squared minus 24x plus 70. Okay, so for the example number 3, I'm just going to use the FOIL method. I'm not going to write the whole thing out. Actually, I'm going to rewrite the problem so I've got more space. 2x plus 3y. Okay, so I'm going to start with the first term. So that's first term of each binomial. I'm going to get 4x times 2x gives me 8x squared. Now I'm going to multiply the outer terms. So the outermost terms of my 2 binomials would be 4x times 3y. So 4 times 3 is going to be 12. X and y are not like terms, so I'm going to have just xy. Now I'm going to do the inner terms. So plus 8 times 2 is 16, and y times x is just, again, going to be xy. I'm writing in the same order as I did before. Yx, xy. It doesn't make a difference. Now I've got to do my last terms. So 8 times 3 is 24, and y times y gives me y squared. My last step here is I got to check and see those ones right there. These are like terms because they both have an x and a y. That's the same in both. So my end answer, let's get the color back. 8x squared, 12 plus 16 is 28xy plus 24y squared. Okay, at this point, if you feel pretty confident that you kind of get how to do this, go ahead and finish the rest of these problems by yourself, and then fast forward just to make sure that you check that you got the right answers. I'm going to continue working them out one at a time, but if you feel good about it at this point, go ahead and try to work it on by yourself. All right, I am going to do distributive properties, so I'm going to take 6a and multiply it by a squared minus 3, and I'm going to take 2 and multiply it by a squared minus 3. Okay, so when I distribute this, I will get 6a cubed minus 18a plus 2a squared minus 6. All right, so I'm looking through, and this has a cube, this has a power of 2, power of 1, and then a constant. So none of these are like terms. I just want to make sure that I write this in standard form, which needs to go highest exponent to lowest exponent. So I'm going to switch these 2 spots because 2 is higher than 1. So 6a cubed minus 2a squared minus 18a minus 6. And there's my answer. This one I'll do again with the box method just to give us another example. I'm going to have 8g and negative 3 and negative 1 and 3g. So when I multiply the first box, negative 1 times 8g gives me negative 8g. Negative 1 times negative 3, a negative times a negative is a positive 3. 3g times 8g, so 3 times 8 is 24, and g times g is g squared. 3g times negative 3, that's giving me negative 9g. Now I want to look for anything that are like terms. So this has just a g, this has just a g. So those two would be like terms. This has a g squared, so it can't combine, and this one is just a constant. I'm going to write my answer from the highest degree term, so 24g squared. I'm going to have a total of negative 17g, and then plus 3. There's my answer. All right, number 6 is something kind of tricky because I think your first inclination is just say, oh, I'm just distributing. I'm going to say 5x squared minus 1 squared and be done. But remember that when we square something, that means take whatever it is you're squaring, multiply it by itself. So if I'm taking 5x minus 1 and multiplying it by itself, I will have this. This is how I would think about 5x minus 1 squared. I'm taking the whole quantity 5x minus 1 and multiplying it by itself. Okay, so this is going to be, I'm going to need to FOIL. I'm going to do the FOIL method, so I'm not going to write out the whole distribution, but I'm going to multiply the 5x to both terms, and I'm going to multiply that negative 1 to both terms. Okay, so when I do the first one, 5x times 5x, that gives me 25x squared. When I do 5x times negative 1, I'm going to get minus 5x. When I do negative 1 times 5x, that's also going to be minus 5x. And then negative 1 times negative 1 is a positive 1. My last step is to look here and see I've got those two that both have an x to the power of 1. So those are like terms. 25x squared minus 10x plus 1. And that is my answer. Alrighty. Number 7 looks a little more complicated, but again, we're still doing the same idea. I'm going to take this x and I'm going to distribute it to each term. You could write that out separately, or you can just kind of think about it in your head. But I'm going to have, let me see, I got a little carried away. I'm going to have x times x squared plus 3x minus 6. And I'm going to have 4 times x squared plus 3x minus 6. I'm going to do both of those. So x times x squared is x cubed. X times 3x gives me 3x squared. And x times negative 6 is minus 6x. Then on the next one, I'm going to do 4 times x squared. Be 4x squared. 4 times 3x is 12x. And 4 times negative 6 is minus 24. I have a lot more terms this time, so I'm going to look and see. I see an x squared and an x squared terms. Those are like terms. They both have an x to the power of 2. And I see an x and an x. Those are like terms. They both have x to the power of 1. This doesn't have anything like it, no other powers of 3 and no other constants. So when I simplify, I will have x to the third. 3x squared plus 4x squared gives me a total of 7x squareds. And then negative 6x plus 12x gives me a total of 12x's, and then minus 24. There's my answer. All right, last problem. This is really similar to the other area problem we did when we were doing monomials, but notice this time I have, these are binomials, and this is a monomial with a binomial. So to find the area of the whole of the big rectangle, I need to do length times width. So let's do, I'll use the box method for this one. 4x plus 5. And I'm going to multiply that by 8x times negative 2. Okay, so when I multiply the first square, I will get 8 times 4 is 32, and x times x is x squared. In my next box, 4x times negative 2 gives me negative 8x. Let's see, 8x times 5 is going to be 40x. And negative 2 times 5 is negative 10. Okay, I'm checking to see if I have any like terms, which I do right there. Those both have an x to the power of 1. So I'm going to have a total of 32x squared plus 32x's minus 10. Okay, so that's the whole big rectangle. That's the whole thing. I need to subtract away whatever's in that white area. So to find that white area, I'm going to just do 3x times x minus 4, which will be 3x squared minus 12x. So I want to subtract all of that 3x squared minus 12x from the bigger area. So here is my smaller area. I guess I should have made that green or something to match. Here's the bigger area. So that's this whole part, the whole thing. Okay, so when I subtract them, I should be left with the shaded part without that little hole. So remember, we got to distribute that negative. So I'm going to have 32x squared minus 3x squared. So that will be a total of, nope, sorry. That'll be 32x squared minus 3x would be 29x squared. I'll have 32x minus 12x, which will leave me with 20x's, and then the 10 isn't going to change. So my total area, 29x squared plus 20x minus 10. All right, hopefully that gives you guys tons of examples. Now it's just going to be a matter of practicing. It's going to be watch for your negative signs, check your math facts. There's lots of places to make computational errors on these problems, so be careful. But hopefully you understand the main concept is that we are distributing everything from the first polynomial to every term in the second polynomial. However you like to think about it, whether it's by writing out both distributions, by keeping them together, but kind of thinking I'm distributing that and then I'm distributing that, or if you like the box method. But anyway, time to practice, and I will be back on Thursday to answer any questions. Okay, bye.